Kia ora. Let's look at the equations of motion in physics and how to manipulate these equations. So here they are, and I can show them in slightly bigger detail over here. And you'll see that the top two only have three quantities compared to the others, and they only have division involved here, whereas the others have also other terms like addition terms. So we treat them a little bit differently. Let's look at the first two, and you may have actually already met them before. I had actually another one up here with acceleration, but it's done exactly, manipulated in exactly the same way as this. So I will be focusing on this equation. Okay, we have this equation. We want to say solve for displacement. And you'll notice when we solve for displacement that the d stays on the right, but the t that was at the bottom now moves to the top. Why? So here is our original equation. And you'll, to get rid of the t, what you need to do is you need to multiply this top term by t to get rid of the t at the bottom. Because if we're dividing by 2, if we multiply 2 and then get it, so 2 divided by 2 is 1, and 1 times d is still d. So that's why we multiply this by t. But of course, being an equation, whatever we multiply, we have to multiply on the other side as well. So now our t's cancel, and we're left with just d on the right side, as over here is v times change in time. And of course, normally we have our unknown on the left-hand side, so I have to simply flip this around. And notice it doesn't matter whether you have change in time first times v, or v times change in time, because 2 times 1 is the same as 1 times 2. Okay, let's now solve for time. So time is at the bottom. So how can I get this unknown at the top by itself? So if we did the manipulation, it seems to be like a straight swap. And why is that? So what you have here, this is the original equation. V is d divided by t. I multiply both sides by t to get rid of the t at the bottom. And that, of course, you'll see makes it go at the top. But now I've got to get rid of the v because I want t by itself. So I divide both sides by v. The v's cancel out, the t's cancel out on the right-hand side, leaving me with my equation of change in time is the change of displacement divided by velocity. So here were our equations. Let's now look at these bottom four. These three on the left, those two plus this one on the left at the bottom, are similar in that they both have, or they all have an addition function as well as a multiplication function, a times t, 2 times a times d, a half times a times t. They do have square values, but we'll do that in another video. This looks as though it's got an addition function as well as a division function, but we'll see later that this is really very similar to what we have over here. So let's start with this equation. So we want to say solve for time, which means I've got to get rid of a, because it's a times t, but I've also got to get rid of the initial velocity, because it's an initial velocity plus t. So we always deal with addition and subtraction before we do any multiplication or division, because with multiplication and division, we only want one sort of term, not two terms as in v plus a t. So we get rid of the addition part first, and we leave the multiplication part later. So to get rid of the addition, we move the plus vi to the other side, which becomes minus, and that gets rid of the plus. Now, why did it become minus? If I say 2 subtract 2, I get 0, which means nothing. So I do the same thing here. Vi, I want to get rid of it. So I subtract vi, which makes nothing. Okay, but if I subtract vi on the right-hand side of the equation, I must do the same on the left, which means the vi's cancel out to nothing. And I now have the vf minus vi on the left-hand side here. Now, I have to get rid of the a because it was a times t. And like we did right in the beginning, if it's multiplying, I make it divide on the other side. And why is that? Here I'm multiplying, So I have to divide the right-hand side by A to get rid of the A, but that means I have to also divide the left-hand side by A. Now notice this is one single term that I divide by A. So I work out VF, subtract VI, and then I divide by A. But these A's cancel out, leaving me with T is equal to VF minus VI, all divided by A. So that's our equation. If I wanted to solve for VI, it's actually simpler because I have no multiplication factor over here. I only have this addition one. And remember, you always do the opposite. If I'm adding, when you take it across, you subtract. If I was multiplying, when you take it across, you divide. But here it's adding, so to take it across, you subtract it. And so VI is equal to VF subtract AT. Now, as I say, these are very similar in working out or manipulating as this one. So I want to look at this one in a bit more detail because it looks as though I've got an addition and a division, but let's look at it in more detail. So there's the equation, and I want to solve for time. Now, this is really one big term, but because it's sort of got a top part, a numerator, and a bottom part, the denominator, I treat that as the multiplication term and I treat that as a division term. But notice that this is one big multiplication term because the line goes under all of it. So when I want to deal with this and get t by itself, you'll notice the 2 that was at the bottom goes to the top, and the VI plus VF that was at the top goes to the bottom. And again, we can do this in small steps. There was my original equation. To get rid of this 2, I multiply both sides by 2. These 2 cancel, leaving me with 2d is equal to VI plus VF times t. Now notice I put brackets in to really highlight this is one term. It's not VI plus VF times t. It's VI plus VF, work that out, times t. So it's not like 2 plus 3 times t where it's 2 plus 3 times t. It's 2 plus 3 is 5 and 5 times t. So to get rid of this term on the right-hand side, I divide both sides by that term. So these on the right-hand side will cancel out, leaving me with t is equal to 2d all divided by VI plus VF. And again, you work out this term first. So like 2 plus 3 is 5. So it's 2d divided by 5. Don't try and say 2d divided by VI plus 2d divided by VF because you're going to go wrong. I hope that is helpful. So kia ora.